Hi. So we're going to go ahead and start off with section 1.1, linear equations. We're going to talk about what is a linear equation, and more importantly, how do we solve them? What does it mean to solve a linear equation? So our first definition is defining a linear equation. A linear equation in one variable, let's go ahead and just say my variable is x. Then this is an equation that can be written in the form ax plus b is equal to 0. In other words, I have a number, let's say a, times x plus or minus another number equal to 0. And this is where a and b are real numbers and a is not equal to 0. One thing I want to point out is that this fancy notation I have right here. This just means a and b are real numbers, like so. So anytime you see this notation, this means again that a and b are real numbers. So this is how we define a linear equation. Sometimes my linear equation may not exactly match this form, but that's fine, as long as I can rewrite it such that it does match this form. Alright, so now that we know what a linear equation is, let's actually talk about how do we solve them. So usually whenever we say solve an equation, I'm trying to find the values, in this case of x, such that whenever I replace my x with that number or expression, then it makes my equation always true. So to solve a linear equation, I'm going to go ahead and follow these steps that I've outlined below. First off, if my equation has fractions, then I can go ahead and take the least common denominator of all of my fractions, and I'm going to multiply both sides of my equation by that number. You'll see what I mean whenever we start getting into some examples here and there. Step 2. Remove any parentheses and simplify as needed. If you recall, we have this thing called PEMDAS, or you may have heard it as Please Excuse My Dear Aunt Sally. We have an order of operations, and we want to simplify when I can. Step 3. Add or subtract such that all terms that have a variable are on one side, and all of my plain numbers or anything else is on the other. In other words, I want one side that has all of my x's, and one side that has all of my numbers. After doing so, I can move on to step 4. I'm going to divide both sides by the coefficient of my variable in order to solve my linear equation. After I believe I have an answer, it's always a good idea for me to check my answers. In other words, I'm going to take what I believe to my answer, and I'm going to plug it back into the original. This way, I can double check and make sure, did I do all of my work correctly? Did I get the correct final answer? Alright, so now that we know how to solve a linear equation, let's go ahead and actually do an example. So starting off with example 1, the instructions are solve for x. In other words, I want to end up with x is equal to some number. In this example, I have 20x plus 40 is equal to 70. So I'm going to go ahead and follow my steps for my equation, on how to solve an equation. Remember that step 1 was if I have any fractions, I can go ahead and multiply both sides of my equation by the least common denominator. Well, for this example 1, there's nothing for me to really do in step 1. There aren't any fractions for me to work with. In other words, I don't have to worry about step 1. Similarly, step 2, there's no parentheses or nothing for me to simplify right off the bat. Hence, I can go ahead and continue to step 3. I add or subtract terms such that I want one side with my x terms and one side with my numbers. Well, if I look at this example, I have 20x, that's my x terms, and then I have 40 and 70. These are my plain numbers. So I'm going to subtract 40 from the left and from the right. If I do that, I get 20x, because I didn't do anything with that. 40 minus 40, that gives me 0. And then this is equal to 70 minus 40. I've got 30. So I'm left with 20x over 30. I have one side with x's, one side with just plain numbers. Step 4 says divide both sides by the coefficient of my variable. Well, here I have 20x. Remember, whenever I'm trying to solve for x, my goal is to just get x by itself equal to some other number. So in other words, I have a 20 in the way. So I'm going to go ahead and divide the left and the right by 20. If I do that, on the left, I have 20 divided by 20 gives me 1x. And on the right, I have 30 over 20. But I know I can simplify this down. 30 over 20, this reduces down into 3 over 2. So I have my final answer, 3/2. And that's how we solve a linear equation. Now that we've gone ahead and done a quick example for example 1, we're going to keep on doing several examples just so that we can get used to it. I'm going to go ahead and move on to example 2. Example 2 has similar instructions. Solve for x. Here I have -3 and in parentheses times x plus 4 all equal to 9. So if I follow my 5 steps for solving a linear equation, step 1, I'm done. There's no fractions for me to work with. Step 2 is to go ahead and simplify my expression if I can. Well, here I have a set of parentheses. I have this x plus 4 inside my parentheses. So if I want to clean this up, I have to go ahead and take this -3, and I'm going to go ahead and multiply, or more formally speaking, distribute my -3 to each of these terms. So if I multiply -3 to each of these terms, I have -3 times x, I have -3x. Then -3 times +4, I get -12. That's my whole left side. And then on the right, I didn't really do anything. I'm just going to leave it alone for now. So now I've cleaned up all of my parentheses by multiplying and distributing that -3. I'm done with step 2. Next, I'm going to move all of my x's to one side and all of my numbers to the other. Well, the quick way for me to do this is I can go ahead and add 12 to the left and to the right. So if I go ahead and add 12 to the left and right, on the left, I'm left with 3x. And then -12 plus 12 gives me 0. So I have -3x is equal to 9 plus 12. I get 21. So now I'm done with step 3. Now, step 4 says divide by the coefficient in front of my x. Well, here I have -3x. So I'm going to go ahead and divide by -3, again on the left and on the right. If I do that, -3 divided by -3, I get 1x. This is equal to 21 divided by -3. I get -7. And I have my final answer. One thing I want to point out, notice that I did not mention step 5. In example 1, I actually forgot to include that step 5. But let's go ahead and do that for this example 2. Let's check our answer. If I want to check my answer, what I'm saying is I'm going to look at my original equation, in this case -3 times x plus 4 equal to 9. And anywhere that there is an x, let me rewrite this real quick. anywhere that there is an x, I'm going to go ahead and replace it with my potential answer. So if I change out this x with -7, I want to make sure that I get 9 on the left and 9 on the right. Let's go ahead and check it out. Using my PEMDAS rules, I have my order of operations. Then I have -7 plus 4. That gives me -3 times -3. And then -3 times -3, I get 9 on the left. And we're for sure that 9 is equal to 9. So this is obviously true. This tells me that my answer was a correct answer. My answer is, in fact, x is equal to -7. Alright, so let's move on to example 3 now. Again, solve for x. This time I have 3 times 8 minus 2x is equal to -15x. What I'm going to recommend is go ahead and pause the video right now and see if you can actually work out this problem. Alright, so did you pause the video and work it out? Or did you let the video continue playing? In either case, let's go ahead and work this problem out together. So, again, going down my steps, step 1, there's no fractions for me to worry about. I'm already done with step 1. Step 2 is I had to go ahead and get rid of my parentheses. Here I have 8 minus 2x in parentheses. So, just like before, I'm going to go ahead and distribute my 3 to both of these terms. If I distribute and multiply, I get 3 times 8, giving me 24. And then 3 times -2x, I get -6x. And then this is equal to -15x. On the right, there wasn't really anything for me to clean up. Alright, so continuing from here, my next step is moving all of my x's to one side and all of my numbers to the other. Usually we've been keeping our x's on the left, but really there's been nothing that's been keeping me from moving the x's to the right. In this case, it's going to be a little bit more convenient for me to move my x's to the right. In other words, let me go ahead and say plus 6x to the left and to the right. If I do that, I'm left with 24. Here, -6x plus 6, well, I get 0x, is equal to -15x plus 6x. I get -9x. Alright, so now I have an equation where x's are on one side and my numbers are on the other. Continuing my same pattern, I'm going to go ahead and divide by the coefficient, -9. And then I'm left with, on the right, x, and then equals. And on the left, I have 24 over -9. Well, this actually simplifies down a little bit. I notice because, well, 3 goes into 24, and 3 goes into 9. So, if I reduce this term 24 over -9 by a factor of 3, I actually get 8 over -3. And one thing I want to point out is that 8 over -3, I could also write this as, well, -8 over 3, or negative on the outside, 8 over 3. These three expressions all mean the same thing for us. It doesn't matter if I have a simple -8, positive 8 on the top versus a -3 or a positive 3 on the bottom. As long as they all, overall, I'm still negative. So I have what I believe to be my answer. And once again, if I want to, I can plug this back into my original equation. In fact, I have it 2 spots to plug it in. And then I can check my answer. If I got the correct answer, I should be getting the same number on the left and the same number on the right. So you can go ahead and check your answer if you would like. We should definitely get that this equation is true whenever I plug in 8 over negative 3, or again, if you want to say negative 8/3, that's still the same answer. So we're done with example 3. Now let's finally get into some more complicated ones. Let's see what happens whenever I look at example 4. Solve for x, same instructions. Let's go ahead and look at 7 times x minus 1 plus 5 is equal to 3x plus 2 times 2x minus 1. So I have a lot of parentheses here. However, fortunately, my process is going to be the same. So, step 1, there are no fractions to worry about, so I don't even have to worry about step 1. Step 2 is clean up my parentheses. So once again, to clean up my parentheses, in this case, I'm going to go ahead and distribute as needed. So starting on the far left, I can distribute my 7 to x minus 1. So if I distribute 7, I have 7 times x, which gives me 7x. 7 times negative 1, I get negative 7. And I still have a plus 5 here. So that's what I have on the left. On the right, I have 3x. There's no parentheses for what I have there. Plus, again, if I distribute this 2, I get 2 times 2x, or in other words, 4x. And then 2 times negative 1, giving me negative 2. So, by distributing, I've gone ahead and got rid of my parentheses. Moving to the next step, well, before I move on to the next step, let's go ahead and simplify. We can combine any like terms before I start moving things around. On the left, I can combine negative 7 and positive 5. Negative 7 plus 5, I get negative 2. On the right, 3x plus 4x, I also get 7x minus 2. So I end up with 7x minus 2 is equal to 7x minus 2. This looks a little interesting to us. I got the same thing on the left, and I have the same thing on the right. Let's say you didn't notice, I can still try to solve for x. Let's see. If I try to move my x's, let's say to the left, I can go ahead and subtract 7x, subtract 7x. And then I get negative 2 is equal to negative 2. I still have the same thing on the left and the right. If I look at this last equation I have, negative 2 is equal to negative 2. Well, that's definitely true. A number is equal to itself. What does this mean for us? This actually means that no matter what I plug in for x, this equation is always going to be true. If my x doesn't matter, that means my answer should be all real numbers. I'm going to go ahead and use my fancy notation for all real numbers. It kind of looks like an R, but with an extra vertical line next to it. I'll also take if you just write all real numbers. Both of these mean the same thing. All right, so for number 4, example 4, every x works out. You can test this out. Choose your favorite number, plug in for x, and you should always get that this equation is true no matter what. So this tells us that it is possible to have every single real number as a solution. We don't always necessarily have just x equal to a number. We could have all real numbers. Now for our last example, let's go ahead and solve for x. We have x divided by 5 minus 1/2 is equal to x over 6. First thing you're probably noticing, I'm going to guess, is that there's fractions here. Well, now I can finally work with that step 1 for my 5 steps to solving a linear equation. Remember, step 1 said if I have fractions, I'm going to go ahead and multiply by the least common denominator. Well, let's go ahead and look at our denominators here. Between these 3 fractions, I have a denominator of 5, 2, and 6. So I want to find the least common denominator between these 3 fractions. In other words, I want a number that 5, 2, and 6 all go into. So if I compare these 3 numbers, the first number that comes to mind for me is actually going to be 30. So let's go ahead and just write that as a note. I have 30. 5 definitely goes into 30. 2 definitely goes into 30. And 6 definitely goes into 30. If you got some other number, like for example 60, that's still fine. It just means that later on in the problem you'll have to do a couple of extra steps, but it should still work out in the end. Here my least common denominator is 30. So, as my instructions stated, let's go ahead and multiply both sides of my equation by 30. So, whenever I multiply both sides by 30, on the left, I have 30 times x over 5. Well, whenever I multiply this out, remember, this is essentially me saying, what's 30 times x, and then divide it by 5. Or you can also read it as what's 30 divided by 5, and then times x. In any case, I get 6x for my first multiplication. Now I also have to distribute to the second term. 30 times negative 1/2. Again, you might read this as 30 times negative 1 divided by 2. Or you can say what's half of 30. Or you can just say what's 30 divided by 2. They all mean the same thing for us. So, if I do 30 divided by 2, I get 15. And it's also negative 15. I have positive 30 times negative 1/2. Remember that we know that a positive times a negative does give me a negative. On the right, I have x over 6 times 30. Again, I can read this a lot of ways. You can read this as what's 1/6 of 30. Or maybe you can read this as 30 divided by 6 times x. 30 divided by 6, I get 5. And I still got my x here. So, the reason why I did the step 1 is that by multiplying it by the least common denominator, I actually got rid of all of my fractions. So really nice if you're not a big fan of working with fractions. One other thing I want to note is that if you've learned a different way, sometimes if I look at this, I could have gotten a common denominator and multiplied by, for example, on the left 2 over 2 and then 5 over 5, and it would still work out. I would accept either method as long as they are legitimate math methods. Anyway, back to my problem. Now I have 6x minus 15 is equal to 5x. Now I can go ahead and start moving my x's and my numbers from one side to another. So for convenience, let's go ahead and move my 6x from the left to the right. So to do that, I can go ahead and subtract 6x from the left and the right. If I do that, 6 minus 6, I get 0x. Minus 15 is equal to 5 minus 6x, I get negative 1x. Or I can just write negative x. We don't usually write 1 as a coefficient in front. But if you want to, that's not a problem as well. All right, so I'm almost there. Again, remember, I want x by itself. But here, I have negative 1x. All I had to do is divide by my coefficient. In this case, I'm going to go ahead and divide by negative 1. Giving me on the left, negative 15 divided by negative 1. A negative divided by a negative gives me a positive. 15 divided by 1, that's just 15. And on the right, negative 1 divided by negative 1, that becomes 1x. So my answer, we believe to be x is equal to 15. And again, if we want, we can plug this back into my original equation just to check my answer. I'd plug it in for this x and plug it in for the first x over on the left. But in any case, this should work out, and hence I have solved for x. All right, so that's the end of section 1.1. We now know how to recognize a linear equation and how to solve a linear equation.